everyone, welcome back to my channel. Today we are going to discuss a subject called optimization techniques. This subject has foundation in mathematics, computer science and engineering. So what's optimization basically? It's a very simple term as we learned in English. Its optimization is basically finding something the best for the given problem. So the definition here suggests that optimization is a process of finding the best solution to a problem. Now, for example, let's consider a problem called finding a best route from your school to your home. Consider this is your home and this is your school. So, you may have one route this way. This could be, for example, 10 kilometers and this is without traffic. And consider this is another way which is 15 kilometers and with traffic. Here we have two possible solutions for our problem of reaching home from our school. So here we may consider this as the best solution to our problem according to the given constraints or the given solutions provided, as this will take them less time to reach our home. So there is another definition here called the process of finding conditions that give minimum or maximum of a function. So here the function defines that it gives a solution to a problem. So finding a solution either of the maximum for a function or a minimum of a function is optimization. For example, here we minimize the amount of time required to travel home. So this is the minimization of the time. That's why it's considered as a minimization of a function. So this is optimization, finding solution which is the best from the available set of solutions. Now let's look into the applications of optimization. There are several applications of optimization. Actually, we use optimization in each and every field of our life. Even for determining a solution for a simple problem, we consider multiple solutions and then get the solution from the best possible solution, right? So this way, the main four applications of optimization are information system. Information system uses the optimization the most. The first and foremost application of optimization is information system. So second one is engineering design. Even in engineering design, we use optimization techniques the most. Supply chain management and operations and manufacturing systems. Even in industries and manufacturing systems, we use optimization techniques. Now we are going to learn about basic terminologies in optimization. So the first terminology is design vector. We all have learned in mathematics what's a vector, right? A vector is basically a set of variables, right? So here, design vector in optimization is a mathematical representation of design variables that define a system or a product. So here, the mathematical vector consists of design variables, different types of design variables which will define the system. So the system is being defined by various design variables, and these variables are represented in the form of a vector, and this is called a design vector. So the next term is design constraint. As we all know, what's a constraint? Constraint is something like a restriction, right? So design constraints limits the possible values of our design variables. So the variables are like design variables which exist in design vector take some values, right? These variables are being restricted to certain values or a limit by design constraints. So these design constraints limits the value of design variables. The next thing is that it rules our design must follow. This gives us rules, like what rules must the design variables follow or the design must follow, like until what extent the design variables can be extended and what are the rules to be followed by our design. So these are the types of design constraints. So the four basic types are physical constraints, performance constraints, cost constraints and environmental constraints. So the physical constraints can be defined as the restrictions on the physical dimensions or physical variable types. For example, physical constraints can be of examples like size, weight and material. So constraints on any of the variable or design variable in terms of size, weight and material is called physical design constraint. And performance design constraint is basically on the performance, on the accuracy, on the speed, on the efficiency of the design. For example, efficiency, speed and accuracy. And cost constraints, as we all know that the problem must be solved within a certain budget or within a certain resources. These come under cost constraints. And environmental constraints can be defined as sustainability constraints and etc. Basically, design constraints are broadly classified into just two types. One is behavior constraints and one is site constraints. Behavior constraints are similar or are equal to performance constraints. So these are the constraints placed on the performance of the problem or the design variable. And these site constraints are basically physical limitations. These site constraints can be defined as the physical limitations of the design variables. So these are the types of constraints and design constraints. And next we would learn about objective function, which is an important and most vital terminology in optimization. So now coming on to objective function, this is another vital terminology in optimization. So what is objective function? We all know what are objectives, right? Objectives are basically what we must achieve in order to reach a goal. So this is an example of objective function in optimization. As we've already seen the definition of optimization, it gets the maximum or minimum value of a function, right? So here we are minimizing the construction cost. This is a type of objective function. Here it is minimizing the cost. It is receiving the minimum value. In objective function, the inputs are design vectors. The objective function takes the input as design vector. As we know, what is design vector? Design vector is a set of variables of system which defines a system or a product, right? So it gives us a value. It takes the input as a design vector of a problem and gives us a value which helps in optimization of the solution. So these can be the type of optimization functions. Objective functions in optimization. First one is minimization function. Here is an example of minimization function where we minimize the construction cost of a problem. So this is a example of minimization function. Maximization function could be maximizing the number of customers, and other one is multi-objective functions. We'll learn about multi-objective functions later in the section. So here we can come across an example where we can define what is a design vector, what is a design constraint, and what is objective function. So the first one comes, suppose we want to design a rectangular bridge with a fixed length L. So the length here is fixed. It's not a variable, okay? And the width W and height H. So here we have two variables, mainly weight and height. Weight is represented by small w and height is represented by small h. So here the design vector can be defined as w comma h because these are the two design variables which will affect the system or which defines the system. And we cannot consider fixed length L because it's already a fixed term and it's not a variable. So the next thing we must define is a design constraint. We already learned what are constraints and what are design constraints, right? What design constraints tells us is that it limits the design variables or it sets rules on the design. So the first constraint we have been given here is that bridge must be able to support a minimum weight of 100 tons. So the weight is given as 100 tons and it's given minimum. We have to give the minimum value. That means that it has to withhold at least bridge of 100 tons. Design constraint for this statement can be written as sigma of w comma h should be greater than or equals to w. Here w is the weight which refers to 100 tons and here w comma h is the width and height. So here this function specifies stress which specifies that the stress among width and height should be greater than 100 tons. The minimum weight should be 100 tons. And then the second function is second constraint is that cost of the bridge must not exceed 1 million. So here it is given that the construction cost of the bridge must not exceed more than 1 million. So this is written as a function of cost c of w comma h. Here the design variables width and height are given should be less than or equals to $1 million. And the next thing we must write is objective function. So the main objective function here is to minimize the cost, and objective function can be written as minimization of cost. Cost function is written as previously the same one, cost of w comma h, which is width comma height. So this is how we write objective function, design constraint and design vector. Let's see about multi-objective programming problem. So as we have seen the types of objective functions. Previously there were minimization functions, maximization functions, and multi-objective functions. So what are these multi-objective programming problem? So as the name suggests, multi-objective, there are more than a single objective. A type of optimization problem where there are multiple objective functions needs to be optimized simultaneously. So there are more than one objective functions, and these objective functions may be like opposite to each other, where one objective function may be conflicted with other objective functions, but we must satisfy or optimize these both objective functions and make a single overall objective function to find a best solution. So this is the problem of multi-objective programming problem, and what we do is we make a single overall objective function and find the solution for that to get the best solution or optimal solution for our problem. So here is an example. It's a very simple example, as we all know. We want to consider or construct a dream theme park, and we have two main objectives here. There can be more than two objectives for a multi-programming. So the first objective here is that we need more fun for the visitors. As this is a dream theme park example, we need more fun for the visitors because that would only increase our revenue. The second objective is that we need to keep the costs down. Even though construction requires more fun for the visitors, we need to keep the costs down. So we have to optimize these both in order that we find the best solution and we make a good dream theme park. So if there are two objective functions like this, we'll consider this one as f1 of x and this one as f2 of x. These are two objectives and these are two different objective functions. And if there exists f1 of x and f2 of x, two objective functions, overall objective function can be defined as f of x is equals to alpha 1 of f1 of x, alpha 2 of f2 of x. This is objective function number 1. This is objective function number 2. This objective function number 1 is more fun for the visitors, and this second one is keep the cost down. So here these alpha 1 and alpha 2 are constants. These constants represent relative importance of one objective function to another objective function. So how important is the more fun for visitors objective function to the keep costs down objective function represents alpha 1, and how important is this to this represents alpha 2. Now we have three basic classification of optimization techniques apart from modern optimization techniques, which we will be discussing in the next video. So the first one is mathematical programming techniques. As we all know, mathematical programming techniques, it's just very simple, which finds minimum or maximum of a function. These are useful to find minimum or maximum of a function. And we have stochastic process of optimization techniques, which includes random variables and probabilistic distribution. And the final one is statistical models. Statistical models involve experimental data, and these uses these experimental data to form some empirical models. These empirical models that are built will find us the optimal solution or helps us in finding the best solution for a given problem. Thank you for watching this video. I hope you all find this good and useful, and for any more suggestions please mention in the comment box, and I hope you all like and subscribe and share this video. Thank you.